right, so the quotient rule is used when you're dividing two expressions. The saying that I usually use to find the derivative when you're dividing two expressions is low d high minus high d low over low squared. That's normally how I remember to do the quotient rule. Now let's write it out in symbols so you can actually see the symbolic way that you see it in your textbook. All right. Let's say that f of x equals some expression u divided by some expression v. That's when you're going to use the quotient rule. So f prime of x, low, which is v low just means the denominator, times d high means the derivative of the numerator, so times u prime, minus, so that's a big difference between the product rule. The product rule's got a plus right there. The quotient rule uses a subtraction. High, which is u, d low, that would be the derivative of the bottom, d prime. So this d just means derivative over low squared. So that's the product of the quotient rule. All right, so let's look at any questions before I show you an example. All right, let's do something like, call this example A. Say f of x equals 3x squared minus 2x divided by x. So we're going to start with low. You always start with low. So low is x. D high would be the derivative of the numerator. What would that be?
6x minus 2.
6x minus 2, yeah. Minus high, which is 3, that's the numerator, 3x squared minus 2x. D low, the derivative of x would be 1, good, over low squared. Now we're going to take x times, distribute the x through that parenthesis. That will give you 6x squared minus 2x minus 1 times that parenthesis would be 3x squared minus 2x all over x squared. Now, this is the place where some people make mistakes. There's two big mistakes I see with the quotient rule. Some people, instead of doing low d high, they'll do high d low. They'll get the numerators switched. The other mistake is people not put parentheses here and they'll forget to distribute this subtraction through. Or they'll try to distribute it through before they multiply. You want to do what I just showed you. Multiply through here, here, now distribute your negative like this. And now we'll just simplify the numerator. So 6x squared minus 3x squared would be 3x squared. And the minus 2x and the plus 2x would cancel over x squared. Normally your answers will end up being a fraction like this. In this particular case though, what could I do to simplify? What's the answer going to be?
3.
Yeah, these x squareds will cancel out, and f prime of x will just equal 3. That doesn't happen very often, but in this case it does. Now, the other way we could have done this is we could have simplified the expression first by just simply dividing both of these by x. So we could have done this. We could have said, let's take 3x squared divided by x minus 2x divided by x. Simplify, so that would be 3x minus 2. And what's the derivative of 3x minus 2? 3. So you can see, number 12 in your assignment on lesson 3.3 is going to tell you to do it both ways and then compare and make sure, notice that you get the same answer either way. All right? Any questions on that? I'm going to show you one more that's going to be a little bit more difficult. But I just wanted you to see an example where you can do it both ways. Sometimes it's tough to simplify first. A lot of times you're going to need to use the product rule because we might not be dividing. U and V might be like a logarithm and a sine function, a trig function. Okay? So eventually, not today, but eventually this is going to get a little tougher. Okay, so this is example C. let's say h of x equals 3x squared minus 4 over 2x to the 6th plus 1. Pretty hard to simplify that before you start. This one you're going to need to use the quotient rule. Again, you use the quotient rule when you have an expression divided by another expression. So h prime of x is going to be low, which is 2x to the 6th plus 1. d high, what's d high going to be equal? 6x, yep, just the derivative of the numerator, 6x. Minus high, which is 3x squared minus 4. d low, what's d low going to be? 12x to the 5th, right? And then don't forget your low squared on the bottom here. 2x to the 6th plus 1 squared. Normally we won't simplify that, we'll just leave that denominator like it is. It's really just the numerator that you have to make sure you simplify. Now make sure you multiply your 6x through and multiply your 12x to the 5th through before you distribute that minus sign. So that's going to give me, if I distribute through here, 12x to the 7th plus 6x minus, distribute the 12x to the 5th through, so 36x to the 7th minus 48x to the 5th. Copy down your denominator again. Once you've got all that done, now you distribute your negative through. If you do it too early, it's going to cause you problems, I think. So I'm going to go plus, negative, plus. Now I can combine 12x to the 7th minus 36x to the 7th is negative 24x to the 7th. And plus 48x to the 5th plus 6x. And don't forget your low squared on the bottom, just leave that as 2x to the 6th plus 1 quantity squared, like that. All right? And what does this equation tell us about the original graph? Just remember what we learned about derivatives. What does a derivative tell you about the original graph? The slope, right? The rate of change at one instant, the instantaneous rate of change. Okay? So this, if I wanted to know the slope or instantaneous rate of change at one point on this graph, I could plug my x value into this equation and it would tell me that. Or this could be a distance time graph. This would be a velocity graph down here. Or this could be a velocity graph up here, and this would be an acceleration graph down here. All right? I think that's enough to get you started on the assignment.